This is Abel, and I'm Bruce, and we're going to show you how to do a correlated groups t-test.
Yes.
Right? Okay, so Abel's first of all going to find our difference scores over there at different. Oh yes, do the totals and the means. 30, totals to 30, and the mean is then 30 over 6 because it's 5. And this one comes up to 84. 84 over 6 is 14. So mean 1 is 5 and mean 2 is 14. Okay, now do in a different color, maybe green or something, or red or whatever, do different scores. Different scores are just either the first score minus the second or the second minus the first. Let's do the second minus the first to keep them positive. 20 minus 8, 12. 16 minus 6, 14 minus 5, gives us 9. Maybe write them a little bigger. 14 minus 5 is 9. 12 minus 4, 8. And 8 minus 2, 6. Okay, now get the sum of the different scores. We'll do the same thing. We'll calculate a mean on those. And if we did it right, the difference between these two means, 14 minus 5, comes out to be 9. So it should be the case that the mean over there is 9. The mean of the difference, the mean of the different scores should be equal to the difference between the means. Okay, so let's see. Sum those all up. 12 and 10 is 22, plus 9 is 31, plus 9 is 40, plus 8 is 48, plus 6 is 54. Yep. And we take 54 and divide it by 6, which gives us a mean. Maybe instead write a big D with a bar over it, so it's obvious that that's the mean difference score. Yes, good. So that's 9. Okay, now let's do our deviation scores for each of those. So a little d like that. Right. Yeah. Okay, so the different scores are 12 minus 9, 10 minus 9, 9 minus 9, 9 minus 9, 8 minus 9, and 6 minus 9. And we square those, and we get 9, 1, 0, 0, 1, 9. Now, you're going to need the room up there to write the t-test, so maybe down here to write the variance. Variance of d, s squared subscript d, will be equal to the sum of those SS, the sum of squares, over the degrees of freedom. And let's see, our sum of squares there is what? We've got 910019, so 20. Maybe you write it right under there and just write SS equals. Yes, good. Okay. And then take the 20 and divide it by degrees of freedom is 5, right? Because there's 6 observations, 6 D scores. 20 over 5 equals 4. Okay, now the formula, whatever color you want to use, T is equal to the mean difference score, small t, lowercase t. Here's a better red if that one's giving you trouble. Oh yes, very nice. Mean difference score. So d bar over the square root of the variance of d divided by n. Yes, s squared d over n. And let's see, you got a bar over the d there, haven't you? Yep. Okay, so start filling those in. D bar turned out to be 9. Put an equal sign here, over square root of 4/6. Let's see, so 4/6 turns out to be 0.667, so it's 9 over square root of 0.667. Oh, 0.667, that looks like a 4, but it's a 6, okay. Yeah, okay, and square root of 0.667 is 0.816, so it's 9 over 0.816. And that comes out to be 11.02. Okay, now we need to do the critical ratio down at the bottom. So use black for that maybe. We're gonna test to see if that thing's significant. So just write out CRIT for critical ratio. Yep, and then underneath it put T. And this time let's go for something really strong, because it is a really strong result. Let's go for T.0005 as a subscript, comma, 5 degrees of freedom, 5 dF, comma, 1 tail. And an equal sign under that. And I'm looking it up on the table now. Let's see, I come over here to 0.005 for 1 tail. I'll go down to 5 degrees of freedom, and it's 6.869. So now you compare those two, and you say, this is way over the top, so we reject HO. Good job.